Hmm. So are there any basic questions on references that we are discussing in our last class? Okay. So references, in a nutshell, it is creating new names, just new names to some existing items, and this is why this is required, that we'll see mostly in this class. And the basic syntax of defining a alias or a new name or a pseudonym for an existing variable. We know we have to use that ampersand operator, and because these are new names to existing entities, that must be initialized whenever you try to use a reference, and that must uh, refer to, or actually it must be um, renaming some existing integer, float, or whatever kind of variables. But we cannot create references of aggregate of integers or array of integers, or I mean the entire array cannot, that reference cannot be created. So but we can create the reference of a particular element of an array. So the array, the entire array name is a, but the some specific element of the array, maybe the second element or the fourth element, if we want, we can create a specific name for that particular element in a collection of uh, in the entire collection of elements in that array. So this is possible. And you can create the reference of a normal integer variable. You can create the reference of a pointer variable also, like in this case. So we have created the, in the line number 47, so we have created the reference of a pointer variable, and here this is this means, so this is a q is a reference, and it is a reference to a pointer, integer pointer variable, and this r1x is a reference to a, to any to a specific integer variable, and references once assigned, that cannot be changed. So let's see that uh, how the passing of reference can be useful. Okay. So if I have got uh, say three functions, I forgot what, some variable int say x equals to 10. I'm writing three functions, f1, maybe f1, I call it as f1 val, where I just pass x, and f1 val, where I pass this one, and sorry, f1 addr, and this is f1 ref. Okay, so this is a local variable x, and I would like to call three functions, f1 val, f1 address, f1 reference. And in the first two cases I have passed this one. So f1 val, it will be something like this. So when I just write x, what does it mean? What is my intention?
Passed by
Passed
value.
by value.
Pass by value. So I'll be having some other variable equivalent to that, which can hold that value. So any other integer variable, say y, can hold it, right? So here if I consider the the stack segment, because this is local and this y is also local to f1 val. So all will be so all the allocations will be done in the stack segment, right? So first of all, so you have got, when you are calling this f1 val, you have got some variable x, because within main this x is there, x equals to 10, and that is a copy of x in the main. And after that you have called this, so whenever you are calling this, the value of x is basically copied to this y. And where x y will be allocated space
In the stack.
In the
in the
stack.
stack segment. So because you have jumped out from the main, so that context of main or all the status of main will be saved here, and then another stack frame, or another entry will be created to deal with f1 val. And in the f1 val, it has got just one local variable, it will be y, and y will simply get the value of x, so that will be, so y will be having the value 10, that's all. And then here if you write y plus plus and you write c out y, so what will be done? Y plus plus means this value will be updated to 11, and uh, if you display here it will be 11, right? Now if you, by exiting, if you write c out x, so whenever this is done, whenever this part is done, again the control comes back here, right? Because it is done, the execution is done. So whenever the control comes back here, what is going to happen in the stack segment here?
Y will be popped.
So because of that, the function call, this value will be popped out, because this call to the f1 is done. So once it is done, the contents that we have made any changes will be completely lost. So now if you write here c out x, it will be displaying
10.
only 10. So there is no impact of that, and that we all know. So that's why we call it as call by value, right? So it is something like, so this is a page having something. So when you are passing it, you are creating a Xerox of a page. So Xerox copy of the page. So this value copied means it's a kind of Xerox copy that you pass on. So and if you write in that Xerox copy locally, so this is me, and I give you a Xerox copy of the notes, and you write something, and then once you leave, so that whatever you have modified is lost. So I retain my original copy, and that gets displayed. Now the second one, here I call f1 address, and I pass this one. So what do I pass here?
Address of x.
Pass by reference.
No, it is not passed by reference. What is this? What is
Address
Address
of
of
x.
what do you mean by
Alias.
what do you mean by ampersand x? What is ampersand x?
Address of x.
Reference.
It is simple, address of x. See, although you see the symbol here, but this is, so this ampersand will be treated as a reference only if it is used in while during declaration. So only if you write here this x, that means this is going to be a reference. Okay. So during declaration only this will be interpreted as a reference. But if you just write ampersand of y, what does it mean? It is same as the previous whatever we know earlier. What is this? Ampersand of x means address of x. Ampersand of y means address of y. Is that fine?
Yes, sir.
So this ampersand of x, anything ampersand of any variable means you are getting the address. That's all. The only point, when you use this ampersand symbol while you are declaring, then that means this is going to be a alias or a reference to something. What that have to specify. But this is not a declaration, right? Is this a declaration?
No, sir.
No, sir.
So here it will be address of x. So what is address of x? So let us assume that the address of x is say 2010. So what we are, and you have got another copy of this function, say f1 address, and so you are passing address. So you should have a suitable variable that can hold address. So what should I declare here?
Int
Integer
pointer x.
pointer.
So some kind of pointer variable, because pointers can only store addresses, and because you are passing the address of integer variables, so I should have a integer pointer, right? So now then if I pass it, so if I just call the function, what it carries with it?
The address of x.
Address of X.
Address of x. So that means it is carrying actually the value what? 2010. Here what value it has carried? The value, the exact value 10. The value of 10 copied. So here you have passed a Xerox copy of that. I mean, this is a Xerox of it. Looks exactly the same, Xerox copy of it. But here what you are passing? You are probably you are passing. So say maybe this is my notes. This is Essence original notes. So what I am giving the CR is not a copy of that that I have obtained from the Xerox machine, but what I am passing him, I am passing the keys of my room or the keys of my Almira, what I where I kept those notes, right? So this address I am passing on, and here how to. So now this P is basically a pointer. So where should P be there? Where
In
the
the
P should
stack.
be stored? So it will be again in the stack, right? So it will be in the stack, say here, and P is just a variable. A pointer variable will occupy some space. We know that all of them will occupy the same space, and it will store what value? 2010, because you are copying the address of x, that is this value you are copying. And once it is done, that means this P is capable of pointing to that location. So P is a pointer because of that. And now using P, if I would like to modify the contents of x, that is possible, because if you have the keys, you can enter the key, open the keys, enter the keys, and take the notes, and you can directly write something on the notes here. So now how to do that? So that is, here we do asterisk P. That means you unlock my room, and then you do something, do some kind of modifications. So what is going to happen? And then maybe you write cout. I would like to display the contents of that, what is pointed. So this is, if I write asterisk P, so that means what? This 10 will be modified to 11 now.
Yes, sir.
So what will be displayed here?
11.
11. And here, if I once I return from this, whenever I return here, what happens? When it returns, this portion pops out, right?
Yes. Yes, sir.
So this is gone. But although it is gone, it retains this value, right? X equals to 11. This is retained. So here, if I write x, so what will be displayed? Now the contents of x has been changed to 11. So it will display here 11. Okay. So these parts we all know. Is that fine?
Yes, sir.
Yes, sir.
Yes,
That's
sir.
why we call it as call by address. So now my intention is to pass not the value, not the address, but a reference of this variable x. So you know what reference means by this time. So if1 reference, so I would have something here that is ready to accept the reference of x. So how do I assign the reference of x to somebody? What is the statement?
So
Int
ampersand.
ampersand.
It
So,
is
so what we do here is, this is x. I would like to assign the reference of x to somebody. Say maybe uh, some other variable, say z, or maybe r. Okay. So if I would like to assign r here, assign the reference of x to r, what should I write here? This one, right? So now I would like to do the same thing here while calling the function. So in this case, what should I write here?
X.
This portion,
X.
this portion should be written here, because to assign the reference of x, you should just mention the symbol x. That's all. And here, the one which is going to which is going to be assigned as a reference, I have to write this part, right? What should I write here?
Int ampersand R.
Is that part clear? So this together, actually is, so that means when you are calling this, you can say that this is assigned to this. So that means this r now acts as a reference of x. So then what kind of change in the stack segment does it take place? So in the stack segment, when you have made a call to f1 reference, what do you see here? Is it something like this? Hmm?
So it
What is
will
the
be
change in
not
the stack segment? Huh?
it will just assign as a name to the X.
Yeah. So my point is, what will be here? Will there be some space also consumed from the stack segment?
No, no, sir.
No, sir.
No, sir.
So this is not. So are you getting me? The notion of reference says that there will be nothing here, right? Hello?
Yes, sir.
So you are just creating another name for this x. Is that fine?
Yes, sir.
Can you see this?
Yes, sir.
Yes, sir.
So now that is what is done. So that is the basic difference. So now you say that within this, if I write here r plus r, I can write plus plus r, because this name r is valid in this scope, right? Because you have defined this r, the name r here, and you are using that name to do something that is possible. So here, if you write plus plus r, what is going to happen?
X will be incremented.
What is r? R is this, so it will be 12. So that means here, if you write plus plus r, it will be made 12, right? But if I write here plus plus x, what will happen?
Error.
Why there will be error?
Because
That is not passed in
in
the
that function X
function.
is not
Yeah, so
defined.
this is not simply not in the scope. So that is the basic difference. So both refers to the same item. So in my home, in my family, if maybe I mean, nobody will call me SN, right? Within my family, with my relatives, nobody will call me SN, because they know with my nicknames and with my good name and all this. So so that name is valid only in my uh, office, or maybe specific to the department. That's all. Because whether I am called as SN or SND, nobody knows. Even in the mechanical department, they do not know. So what is the abbreviation? How can they know? So So that name is specifically applicable in that particular context. We say it's a context. So function is a context. So the point is, the same person you cannot refer to this by this thing. So you have to use a different name. So that's why, so because you are trying to create a different context, you are working in a different context, you are trying to create a reference of that. Why? Because the simple reason, this x, it is a local context. So this is valid in this local context. So somehow you have to uh, create a different a name in this f1 reference functions context, so that you can still access that location. Okay, so the name x is valid here and the name r is valid here, and but both refers to the same uh, say physical location in the RAM or the stack segment. So if I do that, and if I write here cout r, what do you see? What is the value? 12, right?
Yes,
Yes,
sir.
sir.
Yes.
And then if you get back here, what is the change that happens in the stack segment? Nothing in the stack segment specifically, but that symbol that was associated now gets off. So it's just a change you can think of in the symbol table that takes place, but not explicitly in the stack. Is that fine? So now if I write here cout x, what do you get here?
12.
You still get 12. So what you are passing here is passing the reference. So it is, you can say that the reference is passed. So the difference is, it is neither passing the value nor passing the address, but just passing the reference. So that's why this is better known as call by.
Reference.
Now can you tell me what is the basic so which which of the three which of the other two techniques it is similar to call by reference in terms of its impact?
Call by address.
Call by address, because in call by address, I mean, if you pass the address, you have the ability to change the contents of the variable which is actually local to the main, right?
Yes,
And
sir.
in case of reference also, you have the ability within the function to change the contents or update the contents of the variable which is local to the main. So both has the ability, but in the call by value you don't have that, right? If you make some changes, that will not be reflected here. So both has the same impact, or the flexibility, or both has the same power, but which one do you prefer now?
Call by reference.
Why do you prefer this over this? Because both are the same. Just focus on this and try to
Space.
So
hmm?
space, you don't have to create another file.
Space.
So it is
Space.
cleaner.
Yes. And
Yeah,
we
one
don't
is
have to
space, definitely
dereference it.
space. You don't have to, so you don't have to have the storage of the pointer variable just to achieve this. There is one thing definitely true, but what is the other one also?
It is cleaner.
We don't need to dereference it.
Yes, I mean, it's cleaner and compact, right? It's, you just write plus plus r. So as you would have done in a normal case. So plus plus r. So what is this dereferencing and then plus plus and then putting this parenthesis? So all these hassles. So what I mean to say is, your codes will look much simpler and readable. So you achieve the same thing just by writing plus plus r, and you don't have to again go for additional storage. So these are the advantages. So the advantages of using reference. over pointers. One is the space saved, another is uh, the codes are uh, more readable. Okay, there is no asterisks and all these are not there. So these are the advantages. So from now onwards, as and when it is required or possible, you should try to. So why do we pass? So earlier in C, what kind of passing like argument passing techniques were supported in C?
Call by value, call by address.
So call by value and call by address, because there was no there was no reference as such in a pure C compiler. So the concept of reference was not there. So there was no question of call by reference. So call by value was there, call by address was there. Now in C++, because you have the you know what reference means and you can pass references, you probably should should not pass addresses anymore, right? Are you getting the point?
Yes, sir.
Whenever you call a function, whenever you write a function prototype, better not to pass pointers. I mean, not to pass addresses. Because why do we pass addresses? The only reason is I would like to probably in the called function, I would like to update the contents of the location pointed by that address, right? That is the objective. But that you could have done by passing the reference of that, right? So you have got the direct access. So that is the case. So the the simple say analogy here can be like I tell my office that I am SN or maybe yeah, I am SN, but the CR of this particular class uh, treat him as SN, right? So he has got the same powers. So he's just a reference of me. So you just treat the same person like this. So he's also allowed or something like this. Okay, so there is no additional things or additional burden. So that's why the point to note is from now onwards we would not prefer to pass addresses anymore. So we'll always, whenever we need such requirement is there, we will go for call by reference, and so that the code becomes more compact. Okay, so this is all what is there, and I think I have already explained it. So z equals to 10, and then okay, so this z is not actually 10 here, so that it was, there are some other things also. Okay, z was 10, it was 10 without change, with change, but both has the same impact of change. So I would prefer to use call by reference. So this is preferred over call by address. So call by reference is preferred over call by address. If the purpose is to update a local variable by a called function. Okay, so this part is clear. Now focus on this particular code. Now before I get into the details, can you find something strange that is happening in the line 65?
Yes, sir.
We are assigning 5
Hmm?
to a function call.
No, function call is there. That is
We are
quite
assigning
clear. But
an
are you finding something strange that is happening? I mean, in the way the statement is written.
we are
Yes, sir,
assigning
we are
an
also assignment.
Assignment is also there. So what's the problem? But what is the strange thing? Be specific.
Function call is occurring on the left side of the.
Function call is occurring in the left side. Have you ever seen such scenarios in your lifetime? I mean, if you have not used it, so most of the students, have you ever seen that the function call appears in the left side of the assignment operator?
No, sir.
No, sir.
What is this called? This is called the L value, and this is called the R value. Are you aware of these terms?
Yes, sir.
So
Yes.
this assignment operator is a right side, it's a right R value, it's a left side is a L value. So generally when we write functions, say I write f1, say 3, and I then assign it to some x maybe. Or I write say f2 x comma 3.5, I assign it to say y, or maybe it's a pointer, doesn't matter. Or I just write what? F5, F5 say 4.5, comma x. So that also is fine. So either you just call the function without having any assignment operator. If you have got an assignment operator or something like this, you just try to have it always to the R value portion, right? Are you getting my point?
Yes, sir.
Yes.
So the
Yes.
point is, the strange thing that happens, that is something very strange. So is it allowed? First of all, will it be a compilation error? Hmm? Do you think it will work?
Yes, sir.
The thing is, this syntactically this is perfectly okay. Although it looks strange, appears to be strange, but this is okay. And the only way to make it possible, uh, I mean, no functions uh, will be able to be. I mean, you cannot use a function as in the L value part unless the function returns a reference. That's the point. Now, why do we need that? That's a different thing. May appear means if it is up to you. In the L value, only if it returns some reference. Okay, a function can return just one item. So if it is returning reference only, then it is possible. And in fact, you can see here that this function indeed returns a reference, right?
Same reference.
Hmm?
It should
Is that
return
fine?
the same reference.
Hello? Yeah, I cannot hear you. What is the question?
Sir, it should need to return the same reference. I
Yes.
mean,
Now, what
return
we are
reference,
returning,
but
that's a
same
different thing. But
reference.
yes, I mean, first of all, try to accept that a function may appear in the L value, which seems to be strange only if it returns some reference. Now, what reference, whether it's of any use or not, that is a different question. So I'm coming to it later on. But this is the first thing. Only if it returns some reference. Whose reference? I don't know. But this is possible. So if you have done something like this, you can write this. If this is the case, this is possible. Is that okay?
So
Now you see that what is done in the function now. So in the function you have passed int zz. So int zz should have constrained something. So maybe it contains probably 12, I guess. Yes, I mean, so let us assume that zz was assigned 12, and then you are passing, sorry, this z. The integer z is equals to 12 and you are passing the value z here, right? So this is z. So now uh, what type of parameter passing it is? Out of the three, call by value, reference, and address, what is this?
Call by value.
By value.
Now, so just looking into it, can you figure out what is the type? Looking in the statement 65, can you figure out what type of parameter passing it is?
No, sir.
No, sir.
Just looking here, can you figure out? Looking here, just looking here, can you figure out? Because both are same, right? Can you see? Is there any
Yes.
difference? This and this. So call by
No,
value
sir.
and call by reference. Uh, when you come to the calling part, can you figure out what is the difference? Hello.
Yes, sir.
Now can you figure out the difference here?
The ampersand one
No,
in
no.
the function.
Just in the while you are calling the function in that statement, can you figure out is it call by value or call by reference?
No, sir.
No,
Can
No,
you
sir.
No,
differentiate? It is not possible. Only if you check here the arguments that you have declared while in the body of the function, in the declaration definition of the function, only then you can know. So this is basically passing the value, not the reference. So in this case, it is passing the value. It's called by value. Otherwise, this may be call by reference or call by value. And that is the reason, you see, that is the reason if I rename all the functions, because function overloading is possible in C++, right? Function overloading is possible in C++. So uh, can I use the same function name, say f1, f1, f1 to all of these three? Can I use
Yes,
the
sir, you can
same?
use.
Is it
Yes,
Yes,
possible?
sir.
sir, you can use. Yes.
How can it be possible? So if you allow f1, just the function name f1 to be here, so can the compiler distinguish between the call by between these two cases, this case and this case?
Yes, sir.
no, sir.
Hmm? So is it possible? Like, you know that there is a difference here, that is fine. But can you figure out the difference in the calling? Because the compiler otherwise will say that what should I call? Because I know that you have three bodies. But here I don't know. Just writing this, I do not know whether you want to make a jump to this function or this function. Because you say that all the function names are of same name. Are you getting the point?
Yes, sir.
So here function names, so that will lead to some ambiguity because of simple reason that uh, while you are calling the function, you cannot really say that whether it is called by value or called by reference. But if you look here, only then you can figure out. So in fact, you cannot create overloaded functions in such a way that they just differ in terms of call by value and call by reference. So one that accepts a reference, one that accepts a value, because that will be ambiguous. Are you getting the point? So that sort of ambiguity is not allowed. So overloading in that sense is not possible. That's a different thing. So here if I pass here z equals to 12 and you pass here z equals to 12, so here it is a value. So using that value is assigned to what? G. So G is a global variable. So that global variable, what it does, this global variable will be assigned and it will be updated by 2. So if you display the value of G, what will be displayed here?
14.
Hmm?
14.
It's 14. So it is here. Now what I did, I returned G. Let's assume I return G. So first of all, is it acceptable if I would like to return G? The thing is, I would like to, so what it says, I should return. So this return type says that I should return some entity, the reference of some entity. What it means, I am able to return, so this function is able to return the reference of some entity, right? And what is that entity? It is G here. So the G's reference is returned. So what you can think here, as if, so what you can think here is something like this. I mean, after it gets executed, so after the function call is over, you have got something like this, the reference of G. Is that fine? Because we have written G. So what is the type of it? So it's int asterisk, int ampersand. So this is after the function gets executed, you have this one here, and that is assigned the value 5. Okay, are you getting the point?
Yes, sir.
So that is how it works. So now the point is, if I have some other variable, say x equals to 5, and if I would like to return, say, instead of G, if I would like to return x, will it work?
No, sir.
No, sir.
What is the problem? What is the basic
The
problem?
scope of exists just in the function.
Yes, so that's the point. So it's something like, if say you have not seen any of the faculties physically, so it's everything virtual, and you are always believing that probably these faculties are there and they are taking the classes. But say if I refer to some faculty like Professor G Sanyal, so he has already retired 2 years back. Just a minute. So if a entity does not exist, so he is not in the scope of the department, right? Because he has already retired, taken retirement. So now if you try to use his reference, or if you try to assign somebody his reference, does it make sense? So if a student says that, okay, I'll take a LOR from that particular faculty, will it make sense?
No, sir.
Are you getting my point?
Yes, sir.
Yes.
So whenever you are returning reference, you must make sure the entity whose reference you are returning actually exists, or which you are actually returning to be used as a reference actually exists. So can a local variable, say like 5, exist once the control comes out here?
No, sir.
So once the control comes out, automatically the x gets removed from the stack segment. It does not exist. So you cannot really uh, return whenever a function returns a reference to achieve something like this. You can return an entity only which exists. So what kind of things you can return if that's the case?
So dynamically allocated variable.
Global
What's the
and
question?
static.
So you can return anything that is global, right? A global variable can be returned by a function, and also
Static.
which may be global or local. Now if this was static, you can return that, right?
Yes,
Then it
sir.
is possible, because now if it is static, it actually exists. So if you return it here, so you may not access it, but at least it exists. So you can probably return that. So anything that is global or static, you can return those entities a function can return. And here you just have to specify what is the type of the entity that you are returning. The type of the entity that you are returning, you have to specify here, right? So this is one case, and after calling, if you display the value of g, it will be 5 because it is actually taking this say this statement, it's getting executed. Something equivalent to this, it's get executed. Now then, what's the point of doing things? If it is as simple as this, that no matter what the function does, the g will be assigned the value 5, then is there any need to do all these complex like, do we require such a complicated return type and all this? Are you getting my point? So in the line 65, what it appears that g, the global variable, is assigned the value 5 no matter what the function does. Is that okay?
Yes, sir.
That is how we have done it. So if that is the intention, so I could have simply, so you could have simply written like, okay, I write here say function return whatever it is written, I pass here z, and then after that I write g equals to 5. So that also would have the same impact, right? Because doesn't matter what the function does, you are trying to assign the global variable g the value 5. Is that the case? Are you getting my point?
Yes, sir.
So but the case can be something different. Say maybe this is the case. So you have got two global variables, int g and int h. Okay, and then you write the function something like this, int ampersand, then function reference return, and here we have something like int zz, and here you write something like this, the same things, g equals to zz, or say whatever you have received. Say if zz is divisible by 2, then return g, else return h. Now can you see the difference? Can you see the difference now? So if you write here
Yes,
function
sir.
reference return, and there's something like z equals to 5. Now what happens? So sometimes it is assigning the variable, the global variable g to 5. Sometimes it is assigning the global variable h to 5. So it depends what things you have done inside, right? Are you getting the point?
Yes, sir.
But in both the cases, in this particular case, actually, at least we have returned the global variables. We could have returned static variables. Now, can you just give me the example of where such things are essential? Like still you can say that, okay, what should I do all these things? Because I can just write a if else statement, call the function, and then write a if else statement that if the value that you have passed is odd, assign g to k, g to 5, else h to 5. So still you can manage it. So what's the point of returning the reference and trying to complicate things, which it's not apparent or from our.
Sir, excuse me.
Yes, you have a class now.
Yeah, yes.
Yeah. So can you just
Like it's already 9:55. I thought to interrupt you at
yes, yes.
9:45, but you were in a flow, so I didn't.
Mhm. Okay, so let me complete it. Let me just stop the class. So can you just say that where it may be useful?
Sir, when we overload output stream,
Overload output.
when we
Yes,
need to
output
overload
stream.
the OS.
Yes, yes. I mean, so one example is when you are implementing cascaded calls. Cascaded calls. Can you recall? I have explained in most simple terms what cascading means. See out that operator X, then operator Y, operator Y. So like that. When you have a series of cascaded operator overloading calls, so that if you try to implement, you have no other option other than writing a overloaded function, operator overloaded function, or a special operator function which must return reference, otherwise it is not possible. The other one is copy constructor. So these things you will learn later on, but just try to know that what reference means, what return by reference means, what things you can return actually, so that you can relate there. I mean, the applications will be there as and when required, but try to appreciate that why we should not uh, pass addresses from now on, and where probably the return by reference is inevitable. I mean, you don't have any other option, it is mandatory for you. So you have to wait for a while to know why it is so, for those who have not used C++ as a language. Okay, so any more questions?
Sir, what was that chi-square value in the assignment that you gave?
Which one? G?
In the random generator, you have told to find the chi-square value.
Oh, chi-square test. Chi-square test, I can, you can Google it and find out what it is. So it's a
Okay, sir.
statistical measure of the uniformity of the random samples. So to know the biasness, so it's basically used to know the biasness. So you generate random values. That means in a range of say 1 to 100, you expect that 10% of the values should lie in the range of 1 to 10. 10% of the values should lie from the range 10 to 20, like that, right? It should be evenly sparsed, spread. But it may happen that the values are more tending towards say 80 to 90 rather than 0 to 80. So it is not uniformly distributed. So whether it is uniformly distributed or not, you get it. So you evaluate it using a metric that is or a test that is called chi-square test. You can just Google it and find out.
Okay, sir.
So the thing is, I just mentioned one random number generator function, convolution multiplicative generator. So that one, whether it is truly generating random values in a uniformly spread random values, or it has got some bias towards lower values or higher values or middle values, they're more clustered like that. So how to evaluate it, so how to test it? So chi-square, if it is within a particular range that the test results, then you say it's truly random, and I'm happy with that. Otherwise you say that no, my either the seed value or the initial values are such that it has got some bias and it is not random. You're getting my point?
Yes, sir.
Okay, so try to do it of your own, and if you fail, I can maybe in the next class I can have a small description of that. But I think I've given some materials also, and you can always find. So best thing is to find the wiki. Go to the wiki page and find out chi-square test wiki. Just get it there. Then congruential random generator wiki. Find it out there. And the initial values I have given, if you try with that, hopefully it will have a acceptable chi-square result. Okay, anyway, I'm already, we are late. If there are no more questions, thank you, I'm leaving.